Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to talk a little bit about asteroids and a little bit about comets. But before we do, I am going to have a look in my catalogs of objects behind the search window here. So in the most recent video, I showed off some of the basic features of Stellarium. It was more of a walkthrough of the different kinds of things that Stellarium can do. But I'm having a look here to see they don't seem to have a particular class of object. The class of object that I'm looking for, it doesn't seem to be laid out here in its own separate list. But that's okay. At least there is a list of comets and there are a list of a few other objects as well. What I'm looking for are centaurs. So we've got some asteroids here, and we can see them going up to pretty high numbers. Asteroids are generally thought of as the rocky things that go around the sun, and comets are usually thought of as the objects with those big, beautiful tails. And of course, comets do have amazing tails when they're near the sun. But when a comet is further from the sun, it's not going to have that big, beautiful tail because the sun is what takes. We'll take a look at Churyumov-Gerasimenko. This is the comet that the European Space Agency probe Rosetta traveled to and the lander Philae landed on. So this is a comet that we know surprisingly a lot about. Of course, a probe landed on it and took samples, so we know more about this comet than we would about most others. I don't know if an image will be provided for here because it is very quite far away. 6 AU, that's not really that far away. I thought it would be much further. Not getting an image, but this is a short period comet and we're not going to see any tail from it simply because it's not close enough to the sun for a tail to be produced. Now, most of the asteroids that we see in the asteroid belt, those aren't going to be able to produce a tail and probably wouldn't produce a tail even if you brought them closer to the sun. Asteroids in the asteroid belt are rocky objects. Now, the asteroid belt runs pretty much along the ecliptic between Jupiter and Mars, so I know it's going to be somewhere around here. If I get rid of the atmosphere, then smaller bodies will start to be highlighted. There we go. There's one already. There's two already. You know, there are a lot out here. There's another one. I'll see if I can get a close-up of any of these. We'll try 20 Massalia here. Already, we're getting a little bright dot. That is the thing, indeed. And we'll take a closer look. It's a bright object. It's hard, you know. Oh, there we go. We're getting some sort of image. So this even looks pretty spherical. I guess it's not big enough to be under hydrostatic equilibrium. Some things can look like a ball, but without their gravity forcing out any gaps, blowing away any gases, changing their interior so that the heavier things kind of fall towards the bottom and the lighter things float towards the top. A loose aggregate ball of material is still going to be an asteroid, even if it looks pretty round. That's why hydrostatic equilibrium is the actual term for things like dwarf planets and planets. They're not just round, they've reached hydrostatic equilibrium. So there's a bit of a difference there in the meaning of those things. We have a look around. Yeah, there's a bunch more faint ones. 138 Tolosa. Now, this, because it must have been discovered comparatively recently, and that means it's probably not as well photographed or imaged. No, not getting an image there, which is what I expected. That's going to be true for a lot of asteroids. There are hundreds of thousands of them, millions, I think, if we count all of the asteroids, because there are asteroids in the asteroid belt. But many of the objects that are further out by Pluto and by Jupiter, objects known as centaurs, and centaurs have a very particular orbit. So I'll see if I can find any. So those just have the name in it. They're not going to be centaurs, or at least not the kind that I am looking for. Centaurs are very similar to asteroids in that they go around the sun pretty much in a circle, so they don't usually produce tails. However, because they are outside of outside of the ice line, because they're out by the giant planets like Neptune and Uranus, Jupiter and Saturn, they could, if they flew in towards the inner solar system for any reason, they could, here we go, the solar system observer. This brings us up to a location where we're essentially looking down on the sun. So, of course, with all of the stars there, it's going to be hard to even spot the planets. We can get rid of the stars. So that's the hotkey S. For anyone who was watching the video about how to use Stellarium and how Stellarium sort of works, then that is one of the hotkeys I didn't mention in that video. So we've got the Earth there. There's Mars. So working roughly between Mars and Jupiter, we might get to see some asteroids popping up. No, it doesn't look like it. The orbits may show us. So if we turn on the orbits of the objects in the solar system, now this is going to be a lot, showing all of the orbits for all of the objects in the solar system. And of course, it's not really all of the objects of everything in the solar system. It's still quite a lot of orbits. Stellarium can only keep track of so much, of course, but there are still a lot of objects in our solar system that Stellarium is aware of, and I certainly don't want to scare my computer too much, but at the same time, it's worth taking a look. So we can see some here that appear to be almost straight lines. That might be Oumuamua, or Oumuamua, the interstellar object that kind of just grazed our solar system without actually orbiting anything. We can see there's some big rings here going pretty far out. I'm assuming this little cluster here is either Uranus or Neptune. It is hard to tell, but there's a bunch of moons there orbiting that object. And we can see the asteroid belt in there. So there are objects, if we take a close look in here, this orbit would be the orbit of a comet. It's spending a lot of its time out here. Yeah, so that's Saturn, Neptune. The other one must have been Uranus. It's spending time out as far as Neptune, almost as far away as Pluto when Pluto is close to the sun, and then falling in towards the sun and heating up, losing gas, releasing volatile chemicals. And that is enough to make a comet. Because it is going to have that beautiful tail. It's what we'd imagine of a comet. Now just here is an object that's just barely crossing Jupiter's orbit. It's only getting a little further from the sun than Jupiter does. But that's probably still enough to make it icy. It also looks like it's passing very, very close to the sun there, which is generally bad for any object. We can also see that some of these some of these shapes here, we can see that curve looks pretty extreme. But they're not circles, they're definitely ellipses. Some of these asteroids are orbiting the sun, not like a comet, not as hyperbolically as that, they'd get too stable, but they're definitely not orbiting the sun in exactly a circle. Even if these asteroids fell in towards the sun, the chances of them getting a tail are pretty small, simply because they wouldn't have as many of those icy, volatile compounds, because they formed too close to the sun. If you are too close to the sun, and that line is in between the asteroid belt and Jupiter, it's around here, the ice line is the line in space where everything inside of it is too hot to be ice. It has to be water vapor, H2O as a gas. On the outside, it's too cold to have vapor. It's too cold to have water vapor. You have to have ice. Ice is the only option. Water isn't an option if you're not on the surface of something with sufficient gravity. When you are in space, ice or water vapor are your only options. Once ice starts to melt, it will turn directly into molecules of water flying around the vacuum of space or whatever sufficiently low gravity environment you're on. It's only when gravity is high enough that ice can melt, loosen up its bonds, but remain bonded together as a liquid without flying away into a vapor. If you're in the International Space Station, there's air pressure to stop the astronauts exploding. They wouldn't explode. It would be bad for them, but they wouldn't explode if there was if they were in a vacuum. It's not quite that dramatic. But once you're not in a vacuum, there can be enough pressure for water to be liquid. In here, in the asteroid belt and inside it, The only option is water vapor if you're in space. If you're not bonded to the surface of a planet, water vapor is your go-to. So these asteroids, they will sublimate whatever ice they had, or more than likely didn't have. They'll sublimate it off into space. The way a comet would when it flies in close to the sun, but they've been doing it for billions and billions of years. They've lost most of the water on their surface. Ceres might be an exception. Ceres might have some ice on its surface, so the ice line might be somewhere inside the asteroid belt. I'd have to double check the exact location of the ice line in our solar system. But outside of it, you get things that are icy. So you get these actual comets, these objects that spend their time far outside the warmth of the sun, but fall in towards the sun occasionally and melt. Of course, there's all of these other things that are just orbiting the sun at the correct distance. They're too far from the sun to get heated up to produce a tail. If they ever fell in, they would, but something would have to disturb them, like the pull of Jupiter, or the sort of cooperative pull of the inner planets. That one's Neptune. Uranus is the one in there. Saturn, Jupiter. So we can see there's a lot of objects crossing the boundary of Neptune there. That one does look like it's only crossing the bounds of Uranus. But the real difference between comets and asteroids is kind of hard to tell, because some asteroids do contain ices. There are what are known as active asteroids. And comets, they really only look like comets because of their strange orbits. And some asteroids could fall into an orbit like this as well, or a rocky body that doesn't produce a tail. If anything from the inner solar system got flung out and then eventually fell back in again, if it didn't produce a tail, it may not get called a comet, even if it fit the orbital characteristics. So asteroids and comets, they're a complicated bunch, as well as the simple ones, the asteroids that are just balls of rock with nothing erratic on their surface to boil away, nothing volatile. And the comets are the distant rocky objects, if there are any, that wouldn't produce a tail if they fell too close to the sun. So, as well as the rocky comets that are the rocky asteroids that are truly rocky, and the comets that are icy and produce a tail and follow them, we've got asteroids that are active and do have volatiles, but probably won't pass too close to the sun to produce a tail. And there are objects that would be comets if they fell close enough to the sun, but they may never. They may always stay far outside those orbits, being Plutinos and Cubenos and Centaurs for the ones that are close to the massive planets like Jupiter and Saturn. So these definitions, as you may remember from previous videos, sometimes they can be a little bit tricky. Small solar bodies, minor planets, there's various other classifications to try and tidy these things up. But if you would like to hear more about it, you can subscribe to my YouTube channel. I'm sure I will talk about more of this in the future. If you enjoyed this video looking at these different objects and seeing the solar system from the outside, make sure to like this video. And if you'd like to read some of this information, you can head to my website, quevinscontent.ie, and hopefully I will see you back here next time.